Okay, so in lesson 3, we're going to carry on with Darwin's theory of natural selection, and we're going to take a look at the different ways that that can happen in a population. So at the top of this lesson, there is a video that reviews what natural selection is, and again, it draws on some good examples and gives you some visuals as to how natural selection actually looks. But it's up to you if you want to watch it. I've also given you a spiel down here just to remind you. And the big thing that you want to remember when we're dealing with natural selection is that it operates on the phenotypes of individuals in a population. So what that means is the individuals who are best suited because of their physical differences to a certain environment will have a higher chance of surviving and thus have a higher chance of passing on their genes. And when we look at evolution, that's what it's all about. One of the earlier topics we explored in one of the first lessons was evolutionary fitness. And again, that just refers to the ability of an organism to pass on its genes. And the more it passes on its genes, the more evolutionary fit it is considered. And so whatever adaptations are going to help an organism be better adapted or better suited to an environment, natural selection can act on those phenotypes and cause populations to shift over time because some of those differences will make organisms more suited for that environment. So if you come down here, we're looking at an example with beetles again. And I've given you a thought question that says, using the image above, explain how it illustrates the process of natural selection. So this is a quite easy example. You can see there's two different colored beetles, green and brown, although it looks orange. And so if you look over the first couple of generations, you can see that slowly green beetles are being preyed upon more heavily by these birds. And over time, the population of these beetles is shifting to be more predominantly brown. And so if we look at the green beetles, you can see that they're going to probably stand out more to the birds, and thus that's why they're being preyed on more heavily. Whereas these brown beetles, again, even though they look orange, are going to blend in better with their environment, and so are going to have a higher chance of survival. It doesn't mean that no brown beetle will be eaten, but it just means that they will have a higher survival percentage because it's harder for the birds to spot them and prey on them. And so the population of beetles over time can shift to being more predominantly brown. And so I want you to highlight that here, talking about how this illustrates the process of natural selection. Part B is the real guts of this lesson, and we're looking at the different types of natural selection. And there's 3. So again, we've given you a video here, and you can stop this video and watch it if you want. It does a really good job describing the 3 different types and giving you some examples. So you can either watch that video or I'll continue to talk about it here, but again, this will give you a bit more information as I'm just going to quickly go over this. So the first type of natural selection is called directive or directional selection, meaning that the phenotypes are going to move in one direction. So one of the most common examples, and you'll get to do a lab with this in our next lesson, is looking at these peppered moth populations. And so in these peppered moths, we can have light colored moths or we can have more dark colored moths. And before the Industrial Revolution, so these moths hang out predominantly on birch trees, so light bark trees. And so before the Industrial Revolution, the light colored moths would be able to blend in better with that environment. The lighter the trees, the better it was for the light moths. So you can see this is representing the original population where light colored pepper moths were favored. But once the Industrial Revolution started to roll around and there was more pollution in the air, some of that pollution was deposited as soot on trees. And so these birch trees actually became darker over time. And so now all of a sudden there was a shift. And that's what this red graph here is trying to represent, is that there was a shift in the phenotypes of the population. So all of a sudden now the darker moths were better adapted to those darker covered trees. And now the light colored moths would stand out more to the predators. And so that's why it's called directional selection, because it's moving in the direction of another phenotype. So I've asked you to think of another example of this type of natural selection, and this can be any hypothetical situation. You can pick any type of animal. So let's say giraffes, for example, where originally you can have 3 different heights of giraffes, and I find it easier if you draw out a graph because it might make more sense. So let's say we had giraffes that were 1 meter, 2 meters, and 3 meters in height. Okay, the averages in terms of height in this giraffe population. And let's say over time, or originally, the giraffe population that was around 1 meter was able to feed on, lower lying plants because that was predominantly in the environment. But over time, those low-lying plants were depleted, and so now in the environment, what was left over was more taller plants. And so the taller giraffes would have an advantage because they would be able to eat those. And so we would see a shift in that population where now taller giraffes had an advantage over the shorter neck giraffes. So just given to any hypothetical situation like that, after this lesson, there's going to be a worksheet. So you can always come back and recall examples you found from that worksheet as well. So I'm just going to erase this so it's out of the way. So your second type of natural selection is called stabilizing selection. And stabilizing selection is selecting for the average phenotype in a population. Say for the average phenotype. And you're selecting against the extremes. And I'll show you what that looks like. So in this example, we're looking at robins, and it says that they typically lay 4 eggs. And larger clutches may result in malnourished chicks because there's too many chicks to feed, while smaller clutches may result in no viable offspring. So you can think about, here's your average at 4. This can be about like 1, and we'll say this is maybe, 7 or 8. Okay? And so if you're only having a clutch of 1 or 2 chicks, you might not have enough healthy chicks that they're able to survive in the and your offspring are able to continue on and thrive. If you have too many, you might not be able to feed them all, and some will likely die again. So your original population will start to narrow down to what this average phenotype is, and you're selecting against those extreme phenotypes. Okay? And so you can see now the population after natural selection has shifted in favor for robins having clutches around 4 to 5 chicks. Another example of this is with humans and birth weight. So again, I'll draw a little graph over here. So let's say that the average for a baby is 6 pounds, and if we're going to one extreme, if it was a premature baby, maybe we're going to small like 2, and high might be 10 or more. We'll say 10 or more, and we'll say this is 2 or less. And so if a baby is too small, it might not be healthy enough to survive. And if a baby is too large, it actually might cause complications for the mother when it's being born. So over time, again, we would have our original population like this, but over time, that average birth weight has been selected for. So you get this stabilizing effect, because this is where you see the most success in healthy babies. So just another example there. Okay, and so your last type of natural selection is called disruptive. Helps if I spell it correctly. Disruptive selection. And so in this type of natural selection, you are selecting against the average phenotype. So kind of opposite of what we just did. Selecting against the average phenotype. And you're selecting for the two extreme phenotypes. And again, when we say extreme, we're just talking about, if we're looking at this blue bell curve here, we're just talking about the phenotypes you would see more at opposite ends of that curve. And so in this example, it says, hypothetical population, gray and Himalayan, which are gray and white rabbits, are better able to blend in with a rocky environment than white rabbits, resulting in diversifying selection or disruptive selection. So you can see here, we have these darker colored rabbits, this is white and gray rabbits, but the ones that are just white, that kind of in between, do not blend in better with the environment. So this average phenotype is going to be selected against, and instead you move in favor of the two other phenotypes. And so you can see that shift in the population here, where we'll have a predominant number of both dark rabbits and these white-gray rabbits as well too, because both would have success at blending in with that environment. Okay, one of the other examples that you can use for the question underneath is in relation to fish size. And so sometimes you can, so let me draw another graph. So let's say this is average size of fish, this would be small fish, and this would be large fish. Because again, you can have diversity in the size of fish in a population. So let's say that here's your original population, okay, and most are around the average size. But over time, the larger the fish, the more successful it was at, fending off predators, or maybe more successful at catching prey. But the smaller fish might have been better at hiding from predators. And so the average fish might be more consumed over time. And so again, you can get a shift where there's success in the small fish, less success in those average size fish, and success in the larger fish as well too. And so you can get that disruptive selection where the two extreme phenotypes are being selected for. Okay, and so that's it. We just wanted to go over those three types. And now we would like you to complete this worksheet drawing on these examples of natural selection.